Our next topic after doing the chemical properties of metals is reactivity series of metals. From chemical properties, we know some metals are more reactive as compared to the other metals. So when we arrange all these known metals in order of their reactivity, then that series is known as reactivity series. So the reactivity series is actually a list of metals. In this we write the metals, and how we write these metals in their order of reactivity, and I'm arranging all these in decreasing order of their reactivity. So the activity series or reactivity series is a list of metals arranged in the order of their decreasing activity. So now here I am writing some of the metals according to their decreasing reactivity. First I am writing is the potassium, then sodium. I am using the symbols of these metals: magnesium, aluminium, zinc, iron, lead is a non-metal here, hydrogen, then copper, mercury, silver and gold. So all these I'm arranging like this. As we go down in this series, the reactivity is decreasing. So most reactive metals are on the top and the less reactive metals, they come at the bottom of this series. So this series is known as reactivity series of metals. So why this non-metal hydrogen is here? Actually, the comparison of these metals reactivity is by taking the hydrogen. So all the metals which are above hydrogen are more reactive than hydrogen, and the ones which are below hydrogen are less reactive than that of hydrogen. Now to learn this series, you can use one mnemonic, that is, this is K. From the K you can learn Kashi, Nath, Ka, Mali, आलू ज़रा फीके पकाता है. काशीनाथ का माली आलू ज़रा फीके पकाता है. कौन है आगे आए? When you say this thing that काशीनाथ का माली आलू ज़रा फीके पकाता है, then Mali will get angry and he will say कौन है आगे आओ. So like this you can learn this series, that's a reactivity series of metals. So this is to understand whether the displacement reaction can take place or not. So the more reactive metal can displace the less reactive metal from its salt solution. So this series will help in understanding the displacement reactions. Now after this I am taking one small topic, that is anodizing. What is the meaning of anodizing? Anodizing is from anode. This term is coming from anode. Now what is anode here? In this case, we take aluminium, and on aluminium, there is a coating of oxide. A layer of oxide comes here on the top of this. So this is the oxide layer, and this is aluminium. A process of forming a thick oxide layer. A process of forming a thick oxide layer of aluminium on this aluminium is known as anodizing. Now aluminium here, it develops a thin oxide layer when it comes in contact with air. So if we keep any aluminium article outside, then what will happen? There will be a very thin layer of oxide, because this aluminium will come in contact with oxygen, and because of this, this oxide layer will form. And this oxide layer, because of this, this aluminium will become resistant to corrosion. Because when this layer will be there, oxygen will not be able to go inside and attack this aluminium. So in this case, the aluminium can be well protected from corrosion by this oxide layer. And this resistance of aluminium can be further improved if we make this oxide layer a little thick. Then resistance of aluminium will be further improved. But how this thick oxide layer is formed on the surface of aluminium? The process here is called anodizing. So during anodizing, a clean aluminium article is taken, a thing made up of aluminium is taken, and this is made anode and is electrolyzed with dilute sulfuric acid. Now, in electrolysis, when we do electrolysis process, in electrolysis we need three things. One is a container in which electrolysis phenomenon takes place, and this container is generally made up of glass. A glass container is taken in electrolysis process, and this container is known as a cell, and this is electrolytic cell. This is the first thing that we need in electrolysis. Second thing that we need is two electrodes we need here. These can be the graphite or these can be of platinum. So electrodes are taken here. One of electrodes is connected to the positive terminal of a battery, and another electrode with wire is connected to negative terminal of a battery. The one connected to positive terminal is acting as anode, and the one that is connected to negative terminal of battery, this electrode acts as a cathode. So one thing is we need a cell, second thing is we need electrodes, and the third thing that we need in electrolysis process is some electrolyte here. Electrolyte we take, either we can take a molten solution here or we can take aqueous solution here. In this case, this electrolyte is dilute sulfuric acid. So this one for anodizing is dilute sulfuric acid. And anode here is a aluminium. Aluminium article is made an anode. This is aluminium. And when these two wires are connected to the positive and negative terminal of the battery, what will happen? The current will start flowing into this cell. And as a result of this, what will happen? On anode, there is evolution of oxygen gas. This oxygen gas which is evolving here at anode, this will start reacting with this aluminium electrode only and will start forming an oxide layer on its surface. And this oxide layer will not let the aluminium to react with more oxygen, and because of this, this inside aluminium will remain as it is, that is, it gets protected from corrosion now. And this oxide layer which is on the top of this aluminium, this can be dyed easily, and because of this aluminium articles, they look attractive. So this is a process of anodizing. But now to understand one thing more here is how this oxygen is coming here. To understand this better, we have taken here a dilute sulfuric acid. Which solution is here? That is a dilute sulfuric acid here. Sulfuric acid dilute means there is water also in this. So actually, when current passes through the solution, this will break up into ions, H plus ions and the sulfate ions. This breaks up to form H plus ion and OH minus ion. The positive ions, they are attracted by the negative electrode, so they move towards the cathode. So when these H plus ions, they move towards cathode, what will happen at cathode? H plus ions, they will gain electrons and they will change to hydrogen. So which gas is evolving here at cathode is actually the hydrogen gas will evolve here at cathode. Now at anode, what will happen? At anode, there are two ions left here, negative ions. These negative ions are sulfate ion and hydroxyl ion. Out of these two ions, this hydroxyl ion will move fastly towards anode, and this will change to the 4 hydroxyl ions change to water plus oxygen. So which gas is evolving here at anode? So this I explained to you. This is not in a syllabus, but just to understand this thing, that how we will say that oxygen is evolving at anode, it's because When sulfuric acid here, dilute sulfuric acid will electrolyze, then these hydroxyl ions which are formed here, they move towards anode, and from hydroxyl ions, which gas is forming here? Oxygen gas is forming. So this is a process which is known as anodizing. After knowing what is anodizing, next topic we have is the nonmetals. Out of, if we say approximately 118 elements we know, approximately 22 are nonmetals. So nonmetals are less in number as compared to metals. Some examples of nonmetals are carbon, sulfur, oxygen, nitrogen, hydrogen, iodine, phosphorus. These are nonmetals. And nonmetals, they can be solid, liquid also, but one nonmetal bromine that is in a liquid form. There's only one nonmetal which is in a liquid form. Otherwise, mostly these are in a solid or in a gaseous form. Next, we have physical properties of nonmetals. Physical properties of nonmetals. The first physical property of nonmetal is physical state of a nonmetal. Like just now I said, most of nonmetals, they are in a gaseous state at room temperature. Some examples of nonmetals which are in a gaseous state at room temperature are like nitrogen, oxygen, chlorine, and helium. These are in a gaseous state at room temperature. But some of the nonmetals like carbon, sulfur, phosphorus, they are in a solid state at room temperature. And one nonmetal, that is Br2, is the only liquid nonmetal at room temperature. So this is about the physical state of nonmetals. Next is the luster, shine. Nonmetals, they are dull in appearance. They are dull in appearance. They don't have any shiny surface. But one nonmetal, iodine, has a shiny surface. Next we have is the third physical property, that is malleability. Malleability means if we beat non-metal, we cannot get the thin sheets by hammering it. So there is no malleability in case of non-metals. Malleability is the property of metals. So the non-metals cannot be beaten into thin sheets by hammering. They will break into small pieces. So they are not malleable in nature. After malleability, next physical property of non-metals is ductility. Non-metals, they cannot be drawn into wires. Metals can be drawn into wires. That property of metals is known as ductility. But non-metals, they cannot be drawn into wires. So there is no ductility in case of non-metals. Next physical property of non-metals we are taking is hardness. Non-metals generally are soft. They are not hard non-metals. Generally they are soft. They can easily break. But there's one exception we have here, that is if we take carbon, and there are allotropes of carbon, graphite and diamond. So carbon in the form of diamond is the extremely hard substance. This is the hardest substance known in nature, that is the diamond. So one exception we have is carbon non-metal is extremely hard in nature. Next physical property after hardness is, that is the sixth physical property, density. Density means how closely the particles are packed together. More closely the particles are packed together, more is the density. But non-metals generally have low density. Non-metals generally have low densities. They are lighter as compared to the metals. Next physical property after density is melting and boiling points. Melting and boiling points of non-metals. Now, if non-metals, they are soft, that means they will have low melting and boiling points as compared to the metals. Non-metals generally have low melting points and boiling points as compared to metals. The reason for this thing is because the intermolecular forces of attraction between the non-metal particles, they are weak. That is why they have low melting and boiling point. This is because the intermolecular forces in non-metals, they are quite weak. So they will break easily, and hence the melting and boiling point, they will be low of non-metals. Next we are taking is the thermal conductivity. Thermal means heat. Non-metals, they do not conduct heat. So if we heat one end of a non-metal, the other end of the non-metal will not become hot. So non-metals are generally bad conductors of heat. Next physical property is electrical conductivity. Non-metals are not conductors of electricity also. Generally we say non-metals are bad conductors of electricity. Now, conduction of electricity is because of movement of electrons. So there should be free electrons for the movement, and then only the substance will conduct electricity. So the reason for this thing is because there are no free electrons. But one exception we have here, that is if we take an allotrope of carbon, that is graphite. So carbon in the form of graphite is a conductor of electricity, is a good conductor of electricity. The reason is because graphite has free electrons in its structure. So when we learn the structure of the diamond and the graphite in the next chapter, we'll do this thing. We'll come to know the structure of graphite is such that there are some free electrons present in graphite. Because of that, it conducts electricity. Next property after electrical conduction is sonority. That is making the, when we are taking the two pieces of non-metals and will struck them, there will not be any sound here in this case. While in case of the metals, when the two pieces of metals, they are struck, then they produce a sound. That property is known as sonority. But in case of non-metals, there is no sonority. Non-metals are non-sonorous. That is, they do not produce any sound. Do not produce sound when struck with a hard substance. Next is the color. Next property, physical property I'm taking is the color. Non-metals, they come in different colors. Most of the non-metals, they are colorless, like hydrogen, oxygen are colorless. Sulfur, this has yellow color. Phosphorus comes in two colors, that is white and red color. White one is sometimes known as a yellow phosphorus also, because if it is left for some time, the white color changes to yellow. And graphite is black in color. Graphite is black. Iodine is grayish white in color. So this is about the physical properties of nonmetals.